Hi, my name is Maria Rosenhammer, and today we're going to learn about binomial expansion using Pascal's triangle. So before we even get to Pascal's triangle, let's talk about binomial expansion. So what does that mean? So here's an example. You have x plus 4 to the second power. So notice that you have two terms inside your parentheses, x and 4. That's where the by comes from for 2. And you have an exponent outside of the parentheses. In this case, it's 2. So if we were to write it out, we have x plus 4 times x plus 4, and we know how to do this using the FOIL method. First, outer, inner, last. So first means that you're multiplying your first terms in the parentheses, so x times x. Outer means you're multiplying your outer terms, so x times 4, which is right here. And then you have inner, 4 times x, which is here, and 4 times 4 is your last term. So when you simplify, you get x squared plus 4x plus 4x plus 16. Now, you have to ask yourself, are you done? Or are there any more terms that you can combine? That's right. 4x and 4x are like terms, so they can be combined and they become 8x. So we have x squared plus 8x plus 16. But what if you have these crazy examples that will give you a lot of headache if you were to use the same method as we did in the previous example? So that's where binomial expansion formula comes in. Okay, if you like formulas, this is for you. A plus b to the n power equals the sum from k equals 0 to n, and so on. It's a whole lot of mumbo jumbo, but again, if you like formulas and you understand it, you're more than welcome to use it. Instead, what we're going to use is Pascal's triangle and some other tricks. So Pascal's triangle is a triangle of numbers. So you start out always with ones, and the ones come on both sides of the triangle, and then inside you have the terms that you add the top two numbers to get the term below them. So 1 plus 1 gives us 2, 1 plus 2 gives us 3, 2 plus 1 gives us 3. So Pascal's triangle is what we're going to use in order to have the coefficients of our binomial expansion. All right, so let's take a look at one of those crazy examples from the beginning, and that's x minus 2 to the third power. So again, if we were to do it the old-fashioned way, we would have to write it out as x minus 2 times x minus 2 times x minus 2, and then multiply it out that way. Instead, we're going to use Pascal's triangle and the trick. So a trick here is that when you have your exponent of 3, your first term is always going to be the exponent. Your second term is always going to be 0. After that, your term that you have here will have the exponent decrease by 1, and this term here will have an exponent increase by 1. Notice that they're always adding up to 3. 3 plus 0 gives us 3, 2 plus 1 gives us 3, so we're still good. Okay? Now Pascal's triangle, remember, gives us the coefficients, and that's where these 1, 3, 3, 1 come from. Okay? Notice that we pick them out from our triangle, the first place where we see a 3, which is this row here. Okay, so that's where our coefficients come from. And then we just have to start multiplying it out. So notice that we had x minus 2. Our binomial expansion formula says that you're always adding the two terms. So that's where the minus 2 in the parentheses comes from, because if we were to rewrite this, it would be x plus negative 2. Okay? So we start multiplying them out, and once we've simplified, we get x to the third minus 6x squared plus 12x minus 8. And that's binomial expansion using Pascal's triangle. So I hope you enjoyed this video, and look for more videos from me. Have a good one. Bye.